Let's try to classify all possible characterization techniques based on different types of processes which can occur. So we have a sample, and to know something about its structure, we expose it to a particle beam. As we said, most often we use photons, but sometimes electrons or newtons are also very useful. What happens when these probing particles interact with our sample? Well, one of the possible results is scattering. The scattering can be elastic or inelastic. A very popular case of elastic scattering is represented by diffraction methods. It can be X-ray diffraction, neutron diffraction, or electron diffraction. Elastic scattering means that the energy of the particle before and after interaction with our sample does not change. Since we have no any dependence on energy, diffraction techniques are by definition not a spectroscopic technique. So please remember that the result of diffraction measurement should not be called a spectrum.
But there are many techniques which are based on inelastic scattering, such as Raman spectroscopy, EELS, RIGS, or inelastic neutron scattering.
Another possible event to occur is absorption, which means that some part of our particles is absorbed inside our material. How can we detect it? So we can measure the number of particles in the transmitted beam through the sample and compare this number with the incident beam. There is a great number of techniques which operate based on this principle. For example, NMR, EPR, infrared and UV visible, X-ray absorption and Mersbauer spectroscopies. But what does really happen when the particle is absorbed? Can it simply disappear? Of course not. Normally, if the particle is absorbed, then we create something else. For example, the particle can interact with an electron and excite this electron. And if this electron can make it out of the sample, we can detect this electron, and this is actually how photoelectron spectroscopies work. But as it often happens in our life, no one can stay in the excited state for too long. So a vacancy left by an excited electron should be filled very fast by another electron. And this will result in a secondary process. For example, we can create a secondary photon. And of course, this is not the only possibility. We call this group of techniques which are based on the secondary processes decay spectroscopies.